The efficiency of schematic diagrams lie not in their artistry, but in the clear and accurate presentation and representation of each component. In order for us to attain these, the following are the characteristics we need to remember. First, it accurately represents the design of an actual circuit. Second, it follows the general conventions of constructing circuit diagrams. And lastly, it offers simplifications wherever possible. Some of the major conventions we can observe when drawing schematic diagrams are: first, we may begin by collecting the relevant electrical symbol from the circuit we are trying to construct a diagram for. We have discussed those already in the previous lecture video. After that, you may place these symbols in your diagram and connect them with appropriate lines and junctions. In placing both outputs and inputs, the left side is where your inputs are and the right side is where your outputs will be, such that the information is flowing from left to right in the circuit. For example, we are asked to draw an appropriate schematic diagram for this pictorial diagram. We see that there is a battery source, a switch, a bulb, which we can call the load, and of course, the wires. We can simply replace this pictorial diagram with this corresponding schematic diagram, identifying which among the symbols should be used. After which, we can easily draw it, such as this. Here is another example. You can pause this video and try this first before we proceed with how to draw this. In this pictorial diagram, we have a switch, which in the problem it says to assume to be closed. There is also an ammeter, a resistor, which are all connected in series to the battery. We can notice as well that there is a voltmeter connected in parallel with the battery. In drawing these, we identify the symbols to be used. Then, starting from the battery, we connect a closed switch. Then connected in series is an ammeter, and then a resistor. The terminal of the resistor is connected in the negative terminal of the battery. There, we have a series connection. Next, we wish to add a voltmeter, which is parallel to the battery. We simply draw it and connect to the terminals of both terminals of the battery. We can note here that in essence, the voltmeter is not connected to any other components except for the battery, which is the component it intends to measure. There we have it. For this last example, let us have this pictorial diagram. The switch, as mentioned in the problem, is open. First, we identify the symbols for each. We have a voltmeter, 4 resistors, an ammeter, a switch, and a battery. We can observe in the illustration that these components are connected in series. Let us assign it as connection A. Then, we have a parallel connection between resistors and a voltmeter. Let us have this as connection B. We will draw first the connection A. Starting from the battery, we will connect a switch in its positive terminal. We always start in the positive terminal because that is the direction of the current. After a switch, we will be connecting a resistor, then an ammeter, and another 2 resistors. Now, we have completed the connection A. Next, we will be doing the parallel connections. We have one resistor parallel with this resistor, then another parallel connection for a voltmeter. Always remember that an ammeter is always connected in series, while the voltmeter is connected in parallel with the component it wants to measure. Quite easy, right? Let us check what you learned so far. I have here an assignment for you to work on. Make a schematic diagram of each, and we will discuss this in our next meeting. I hope it is clear. In case you still wish to explore more, there are many other open sources and simulations available in the internet for you to practice. But that is all for this lecture. I am Gilmer De Castro, and see you in the next video.